Okay, now I will go over the remaining problems that I'm offering as extra credit and extra SAT practice. So Nate walks 25 meters in 13.7 seconds. So that's the proportion given, or the rate given. So 25 meters for every 13.7 seconds. Which of the following is the closest to the distance he will walk in 4 minutes? So first thing I need to do is convert minutes to seconds. So I know that every minute has 60 seconds in it. So 4 times 60 is 240 seconds. So I know I have 240 seconds, and I want to know how many meters that is. And now I cross multiply. Okay. This is 6,000. And then divide by 13.7. So, which of the following is the closest to the distance he will walk in 4 minutes? B, 450 meters. All right, number 12. The amount of money a performer earns is directly proportional to the number of people attending the performance. The performer earns $120 for every 8 people. So that's the ratio given. How much money will the performer earn when 20 people attend the performance? So we know the ratio is dollars to people. And now I have 20 people, and I'm looking for how many dollars. So again, let's see. And then divide. $300. All right, next one. All right, this one's a bit tougher. In the figure above, point O is the center of the circle. Okay, line segments L, M, and MN are tangent to the circle at points L and N respectively. And the segments intersect at point M as shown. So basically this is the picture. If the circumference of the circle is 96, what is the length of the minor arc? So you do need to know a couple things for this. One is that this angle out here can tell you something about this central angle. I believe, if I remember correctly, this guy is half of the central angle created by its tangents. So if this is 60 degrees, this one's going to be 120 degrees. All right, so this is half of that central angle. All right, this is called a central angle. Okay, and this is an exterior angle. So I believe it is half. So knowing that this is 120 degrees, my angle here, what I am seeing is that 120 degrees, this is a fraction of the entire circle. So one key point is that an entire circle is 360 degrees. Okay, and the circumference, this is a vocab word that we need to know. This is the perimeter of the whole circle, or the outside line. So it's like if I were to trace this whole circle, the perimeter of the entire circle is 96. Okay, so this is my part. I have 120 degrees out of my whole, which is 360 degrees. And I want to know, what is the part of this arc? So what is this arc that goes with 120 degrees? How much is that if the entire circle, the whole, is 96? Okay, so this is part of the whole circumference. And so now I can set up this proportion and solve. So this is 96 times 120. 11,520 equals 360x. So x is equal to 32. So the length of that minor arc will be 32. All right, next up, 14. So these are all the geometry problems. It's been a while since you've seen geometry, but it's good to review it. In the figure above, AE is parallel to CD. This means parallel. So meaning these guys are going in the same direction, right? And segment AD intersects CE at B. All right, what is the length of segment CE? So because we know that these are parallel, the reason why they had to tell us that was because now we know that these are similar triangles. All right, we know that this angle is the same as this angle. And we know that this angle, by alternate interior angles, is the same as this angle. Okay, and therefore this one is the same as this one. All right, so we have these similar triangles. One where it's 10, so this is A, B, E, and this is 8. And then we have the other one, the one that matches with A is D to B. D to B is 5. And then C to B, we don't know, but we're looking for CE. So we basically we need to know what CB is, because we want from C all the way to E, and we're missing this bit. So we need to know what this is. So we can set up a proportion for this because we know that they're similar triangles, so they're proportional. So you can say that this side, AB, matches BD because it goes from this angle to this angle. These match. So we can call this big triangle to little triangle. So I'm going to go big triangle to little triangle. So 10 to 5 is equal to big triangle to little triangle. And then I can solve for that x. You can also go big is to big as little is to little, as long as you match them up. Either way, you get x is 4, okay? You can also see that this one is double, so like 10, half of 10 is 5, so half of 8 has to be 4. So we know that this is 4, and so the whole length of C to E is 4 plus 8. All right. 15. A curator at a wildlife society created the scatter plot above to examine the relationship between gestation period. So gestation is how long the mother is pregnant, and life expectancy. So how long the animal lives, right? So our gestation as humans is 9 months, and then our average life expectancy is like 77 years or something. So of the labeled points, which represents the animal for which the ratio of life expectancy to gestation is greatest? So life expectancy to gestation. That's a hard word to say. So we want a long life expectancy and a short gestation, if we want to have a large ratio, right? We want our ratio to be bigger, so we want the life expectancy to be big and the gestation to be small. All right, so a small gestation and so A, B, C, D. Small gestation, so this will be life expectancy is like 7. So this is for A. 7 to like 22. All right, and then let's look at B is like 8 to 44. C is 8 to 51. And D is like 10 to 51. So the easiest way to compare all of these is to make them decimals. What I do think is going to happen is that this one is going to be the biggest ratio since gestation is so small. So a small denominator is actually a really big piece, right? 1/2 is way bigger than 1/100th of a piece of pizza. but let's check this out. This is like 0.32. This is 0.18, so that's not very big. And this is 0.19, so I am correct. A definitely has the largest ratio because it has such a small denominator, small gestation. Okay. While preparing to run a marathon, Amelia created a training schedule in which the distance of her longest run every week increased by a constant amount. If Amelia's training schedule requires that her longest run in week 4 is a distance of 8 miles, and her longest run in week 16 is a distance of 26 miles, which of the following best describes how the distance Amelia runs changes between week 4 and week 16 of her training schedule? Okay, so we're looking at, well, one way to think of this is like slope. So we can think of it as in week 4, she's at a distance of 8 miles. And at week 16, she's at a distance of 26. So we can think of it like slope y2 minus y1 over x2 minus x1. Oops, that's 12. Whoa, you didn't see that. Which is, let's see, divided by 3, 6 over 4, which is 1.5. So we can see that Amelia increases the distance of her longest run by 1.5 miles each week. So that's one way to look at it, is to think, okay, she went miles over a week. See if there's another. I'm trying to think if there's another way to do it. I don't think so. Yeah. So we're looking at the increase in miles over the increase in distance. All right, and technically that's really just slope. The increase in miles, 18, over the increase in distance. This is 1.5. All right, last one here. Now it's just time for the challenges. So Tony is planning to read a novel. The table above shows information about the novel. Tony's reading speed and the amount of time he plans to spend reading the novel each day. If Tony reads at the rates given in the table, which of the following is the closest to the number of days it would take Tony to read the entire novel? Okay. So, what do we need to know? Well, we need to figure out how many number of hours Tony plans to read the novel per day. So 3 hours per day. We don't really need to know number of parts or number of chapters. It says number of words Tony reads per minute is 250 words per 1 minute. And we know that she plans on reading 3 hours in 1 day. Okay, number of words in the novel, there's 349,168 words. So we can figure out how many minutes that's going to take her. So 3, 4, 9, 1, 6, 8 for how many minutes? Cross multiply. Three, 4, 9 divided by 250. 1396. This is how many minutes it's going to take her to read the entire novel. So this is how many minutes. We need to figure out how many hours that is. So this is minutes. There's 60 minutes in every hour. So we need to divide by 60. So that's 23.2778 hours. Okay, and we need to figure out, okay, how many days is that going to be? Because we know she reads 3 hours per 1 day. And now we cross multiply again. And then divide. So that's going to be 7.76 days. All right, so she will need 8 days to read that novel. So that was tough because there was a lot of information here that we didn't need. We didn't need to know how many pages there were. We didn't need to know how many chapters or how many parts were in the novel. We just needed to know these rates. Okay, and once we had the rates, we knew, okay, well, I need to know how many words there are. And so this is what came in handy. All right. All right, if a minus b over b equals 3 over 7, which the following must also be true. So there's a few ways to do this. What I might do is just try to get it to look like a over b, maybe. I don't know. I think I'm just going to play with this using cross multiplication. So I'm going to cross multiply and see what happens. 3b is equal to 7a minus 7b. Okay, now I can combine like terms. 10b is equal to 7a. Okay, this is looking kind of familiar, looking at my answer choices. But I do kind of want it to look like a over b. So what I might do now is divide by b so that I can get a over b. And now I don't want that 7 there, so I'm going to divide by 7. And there we go. That's b. All right, so I was just playing with cross multiplying. Another thing you could do is pick an a and pick a b. So like, let's say a is 5 and b is, if a is 5, oh, hang on. Another thing you might do, that was stupid, is just be like, okay, well, b could be 7. And if b is 7, then this has to equal 3 on top, so a is 10. So if a is 10 and b is 7, which one of these would be true? Well, this one wouldn't be true because it would be 10 over 7, all right? And this one, 17 over 7, that's not true, right? You could just plug it in, and we know that b is true because a is 10 and b is 7, okay? So you could pick numbers that make this fraction true, or you could use cross multiplication. Okay, and that is it. So that is all of the SAT practice for rates, ratios, and proportions. Hopefully you got a chance to do all of the problems, more than just 1 through 10. I really think doing as many as possible will get you as prepared as possible. So hopefully you do this video for some extra credit and just some extra practice so that you can be as prepared as possible. Enjoy your weekend.